Hi everyone and welcome in this tutorial. Today I'll be speaking about Datashare and its new Neo4j plugin. And Datashare is ICIJ's most popular open source software. It's a search engine made for investigative journalists, and Neo4j is a graph database technology. And so the plugin that I'm presenting today lets you use Neo4j inside Datashare. And basically, it lets you create graph databases out of your Datashare's documents and entities. And so using both software together should hopefully speed up data discovery, as well as helps you surface links between corporate entities found inside your documents. So today's tutorial will be in two parts and in two separate videos. So this video is the first part, and you'll find the link to the second part in this video's description. So the first part will be introductory, and I will be providing some context, and so I'll show you how to use Datashare to analyze your documents and extract corporate entities for from your investigations documents. And then I'll jump to Neo4j and speak a bit about graph databases and why they are particularly interesting in the case of investigative journalism. And then I'll show you how to use the new plugin to create graph databases from your investigations documents found inside your Datashare projects. And so the second video will be a bit more technical and probably a bit more interesting. And so in the second video, we'll deep dive into the Enron email corpus, which is a large dataset corpus of email conversations, and I will use Neo4j Bloom and Neo4j browser, the Neo4j browser, in order to explore these documents and this dataset. So this part will be more technical than the first one, which is quite introductory. So if you already know about Datashare and Neo4j, feel free to skip the first part and jump directly to the second part. So welcome in this tutorial, thanks for watching, and let's start. So before we start, and I show you how to create graph databases from your Datashare's documents and entities, I'd like to provide you with a bit of context about Datashare and Neo4j and why we think you might be interested in using them together in your investigations. So if you're an investigative journalist working as part of an investigation, you can often get in a case where you get a collection of documents to analyze, but there's just too many of them to read them all. And so in this case, you can quickly get stuck because the information that you're looking for is probably contained in a small subset of documents, and you can read all of your documents. And so because this situation is quite frequent, at ICIJ we've developed Datashare, which we use as a search engine in almost all of our investigations. So with Datashare, the journalists can add documents to the software, and then they can search for the information that they are looking for by typing queries, just like they would do with a regular search engine. And so the software will return them the most relevant documents based on their query and the document's content. In addition, Datashare is able to automatically extract entities from documents. So we're speaking about person names, company names, email addresses, and so on. And so this information will be available to journalists, and they will be able to refine their search using the entities. Today we'll also be speaking about Neo4j, which is a graph database technology. And so if you're not familiar with graph databases are just like regular databases, but instead of storing the data inside tables, rows, and columns, the data is stored inside nodes and their properties, and the nodes are connected together through relationships, which creates the graph. And so storing the data inside a graph rather than in tables is particularly interesting because with your entities represented inside a graph, it's really easy and efficient to basically query your data and try to surface links between the different entities found into the graph database. And so that's why we're using Neo4j a lot, and that we've used it in past investigation, and that's why Neo4j is particularly interesting when it comes to investigative journalism. So because we thought that it was very interesting to use Neo4j to represent the different entities found inside Datashare, I've worked as part of a 10 months Neo4j fellowship at ICIJ, and I've just released a new Neo4j plugin for Datashare, which will let you create a graph from your Datashare's documents. And so the graph will basically connect the different entities which are found inside your Datashare projects, and using different tools and Neo4j, you will be able to analyze this graph and explore it and hopefully reveal links between corporate entities found inside your documents. And so this is what this new Neo4j plugin is about. Before we start the actual tutorial, I have to tell you that a lot of what I'm explaining in the following video is also explained in great details in Datashare's documentation that you can find on this page. And so this is the generic Datashare's documentation, but if you look in this menu, you will find a section documenting the Neo4j plugin. So it will drive you through the graph creation and also really drive you through all the technical stuff. So if you find that some information are missing from the video, please have a look at this page, and it will help you setting everything up and use the plugin, as well as a lot more things. So additionally, I'll be adding a lot of references to this video's descriptions, and that should also help you to explore your data using Neo4j. Okay, so let's speak a bit about Datashare's documents and named entities. So remember that earlier I said that Datashare was a search engine for your investigations documents. So the first thing that journalists do when working with Datashare is to add documents to the software. So there are two versions of the software. One can run on a server and the other one can run on your laptop. So this is the demo version of Datashare, which is running on ICIJ's demo server. And I also have another Datashare running in here locally. And so I'll be using this to showcase how you can add documents to Datashare. Actually, I've already done it in here. You can see that I have many documents on this project. And the way I did it is by creating a new task inside Datashare. And so basically you can click in here and basically index documents which are found on your laptop. So it's supposed to be your investigations documents. So what do we call indexing? It's basically out of any kind of document, try to extract content from it and make it searchable. So if we look in here, we have a lot of documents that have been indexed, and if we look at this document, it's an email in which we can see that the content has been extracted and has been made searchable. So for instance, if we look for this term inside the corpus, we can see that it appears in many other documents. And going back to this document, we can also try to see if we find other documents with the same phone number, which is supposed to belong to this person, and the software will just return all other documents in which this phone number appears. So basically, Datashare has made all your documents searchable. So it's really a search engine for your own documents. So when working with Datashare, the second thing that you would normally do on an investigation is to, after adding documents to it, is to add what we call name entities to it, or rather extract them for the documents. So what are name entities? If we get back to our document, you can see that we have a name entity tab, and the name entities are actually the different persons, organizations, locations, or email addresses which appear inside the document. So you can see that Datashare has automatically extracted them, and what's interesting is that once you have extracted name entities, it is possible to use them to either search by name entities or filter existing search with name entities. So earlier I saw that there was someone named Buckner in the document, and so if I want to filter all of these results to keep only the ones in which someone named Buckner is cited inside them, I can just contextualize the search, and you can see that it has filtered my search to keep only these 3 documents. So yes, that's it about, that's how Datashare works, and you can see that Datashare is basically a search engine for your investigations documents, and that name entities can be used to filter the search inside Datashare. Okay, so now let's create our Datashare's project graph. And the graph that we are going to build will be a document and name entities graph. And so if you remember, earlier I showed that once documents are indexed and that we've extracted name entities from them, we can see that name entities appear inside the document. And so using that information, we can create a graph which will connect entities together through documents. And so if we look at this graph here, we have in orange email documents in which the rest of the nodes which are here appears in. So these 5 nodes appears in this document, and this email address here appears in 3 different documents. And since one name entity can appear in several documents, this will actually connect our name entities together. And since they are connected, we will be able to investigate links between these entities. And for instance, we will be able to explore and create a graph to find out if 2 entities which we are interested in are connected in some way. Okay, so now let's get back a bit to Neo4j and graph databases. If you remember well, earlier I said that graph databases were just like regular databases, but where instead of storing data inside tables, we're using a graph and store information inside the graph's nodes and relationships. So to give you a better intuition of what a graph database is, I'll compare it to traditional relational database. And so for that, we'll look at this example. So basically, we'll try to model the fact that, we'll be looking at the company and links between different entities inside the company. And so to start, we'll look at employees and departments. So with relational databases, if we want to model the fact that a single employee can belong to different departments, we'll create different tables. So first, we'll create an employee table in which each employee will be a row. And so rows will have an ID. So that's what we are seeing here. We have one row corresponding to an employee named Alice. And so in these rows we have several columns, and so here we are seeing the first name column, but we could have many more columns representing the different attributes of each row record. And so if we were to model the fact that employees belongs to different departments, we would have to create second tables. So this is the department table, which is just like the employees table, but for departments, for the different departments inside the company. And so to denote the fact that an employee can belong to different departments, we'll create what's called a relational table or joint table. And so that's what we see here in the middle. And basically, in this joint table, we'll join both the employee and the department tables. And each row inside this table will have on the left an ID from the employee table, and the row on the right will have an ID from the department tables. And so this is how we join the employee table to the department table, and this is how we basically will be later able to look for relationships between these two tables and these two different kind of records. So this was for a relational database. In contrast, if we were to represent the same information inside a graph, we only have nodes and relationships. And so all the records inside the graph are nodes, and these nodes are connected together through relationships. And so you can see that here we represented the same information. So Alice is still belonging to 3 different departments of the companies. And so we don't have any table. So we replace tables with what is called labels in the Neo4j terminology, and basically labels are the different kind of nodes that are found inside the graph. So here we have 4 nodes and 2 different kind of labels. So here it's Alice, and so it's a person node, and on the right we can see that we have 3 departments nodes. And in the graph, the different attributes which were previously found inside the table's columns are directly stored inside the nodes. So here, the name of the employee is inside the person nodes, and similarly, the department name is stored inside the department node. And so we've also replaced the join tables that we had earlier by relationships. And so the relationships are the arrows that we see here. The relationships between nodes can be directed. So here it's directed from the person node to the department node. And you can also see that relationships have a type. So just as earlier we saw that different kind of nodes had different labels, different kind of relationships have different labels. And so this is how you store data inside a graph database. And so you might wonder why we do this. Actually, you'll understand this right now. So now that you've understood what is a graph database and how it's different from a relational database, imagine that we were to query or try to understand how a company works and query, model the company with a much more complex data model, where we model the fact that a person can belong to several projects, that the projects are owned by a company's departments, and that the organization is composed of several departments, and that person can also belong to several organizations. So basically, we've switched from a very simple data model to a much more complex one, and each time that 2 different kind of entities are linked together, and that an entity can be connected to several entities of another type, we've introduced the tables that we see here, which are our join tables. And so when you are investigating the links between entities of different types, you need to basically perform a join through these join tables. And so these are usually very inefficient operations, and this will make it very inefficient to basically try to look for links between your different entities of different types. It will also make it very hard for you to discover distant links between entities of different types, because you'll have to go through many joins. And so actually, in most cases, this will be prohibitive, and you won't even be able to do it. In contrast, with our data represented as a graph, Neo4j is able to directly create a graph and go through the different nodes and relationships to look for links between your different entities. And so this is much more efficient and better suited to basically try to surface distant links between entities found inside your data. And so that's why at ICIJ we've used Neo4j a lot for our investigations, and we've even created corporate registries based on graph databases, and it's called the Offshore Link Database. It's a registry that we created from our past investigations, so from projects like Pandora Papers, Panama Papers, and many more. And so in this corporate registry, you will be able to find basically a graph made out of offshore companies, and in which these companies are linked to their ultimate beneficial owners thanks to a graph. And so all of this was created and powered by Neo4j. So until now, Datashare and Neo4j have been used together, but were not connected. And so that's why we created this Neo4j plugin, which will basically let you create a graph and benefit from the power of graph databases inside your Datashare projects. Okay, so now let's try to have the plugin set up and create the graph. So the first thing that you need to know is that there are many different setups, and so depending on your setup, you might want to refer to this doc, which will let you know how to create a graph. And so now I will quickly show you how to create your Neo4j graph when you're running Datashare locally. If you're running Datashare locally, you will need to have Neo4j running on your laptop somewhere. So there are several ways that you can do so. First, you can use a Docker image. That's what I have here, but you can also use the Datashare, which is running inside the Neo4j desktop, which is this instance. And so here I will be, for instance, starting the Neo4j, which is running on Neo4j desktop, and it's running here. Now if we, the second thing that we need to know is going back into the local Datashare which is running and install our Neo4j plugin, which is called Neo4j Graph Widget. So this is what I'm doing now. And now if you go back to the project page, we see that there's a new Neo4j widget popping, and the Neo4j extension should start running soon. So this is starting, and here we go. We have our new graph widget here, and if I want to create the graph, the only thing that I need to do is to click on here, which should create a task and create my graph. Once the graph is created, you should see, you refresh the page, you should see the number in here matching the number in here, meaning that we have the same number in both documents inside Datashare, inside the graph, and the same number of name entities inside Datashare and inside our graph. So that's what we have here. If later in your project you add new documents to your project, and or you launch new name entity pipelines detecting new entities, figures here will change, meaning that you will need to trigger a graph update so that the graph is updated with the latest changes on your Datashare project. Okay, so this is how you can create your graph using the local version of Datashare. So by now, with this figure here, you should have all of the documents and name entities imported inside your local Neo4j database. If you are using a server version of Datashare, meaning that Datashare is running on the server, you might not have access to the database. If it's the case, we've added the ability to actually export the database so that you can re-import it in your local database. So here we are on the Datashare demo. So Datashare is running on ICIJ's demo server, and which means that I don't have a direct access to the Neo4j instance behind this In this case, if I still want to be able to work with this graph, what I can do is to actually export it by selecting the graph, the cipher shell format, and clicking here. This will download a Datashare dump, and I can use the Neo4j admin CLI to import this dump into my local Datashare. So please refer to the documentation where all of this is explained in details. So that concludes the first part of our tutorial. So by now we should know a lot more about Datashare, Neo4j, and how to create graph databases from Datashare's projects. In the second part of the tutorial, we'll deep dive into the data. So we'll be using Neo4j and different visualization tools to basically try to connect the dots between different entities found inside the Enron email corpus, which is the large dataset composed of email conversations. So please have a look at the second part. You'll find the link to the video in this video's description. And thanks again for watching.